Good evening, everyone. Today, I'd like to present the onRamp, how to send a message. This is the CCIP protocol from Chainlink. Previously, we talked about how we can execute a message on the off-ramp side. So the big picture is like this. We have chain 1 and chain 2, and our goal is we want to send a message from chain 1 to chain 2 and trying to move a token over, or maybe a bunch of tokens, and then execute the message here. So earlier we talked about how we can execute a message on the off-ramp side. Now we're going to talk about how we can send a message from the on-ramp side. And all of these are through down by the router. And in chain 1, we're going to call the router.ccip send, and in the chain 2, the router, on the other hand, after executing the message, is going to call receiver .ccip receive to execute the message. So let's go back to the discussion about how we can have a CCIP send starting from the router. Okay, so the router is actually going to be here. Of course, anybody can call it unless the router is disabled. So they have this modifier over here to control, to pause it. So the first thing you are going to do is you are going to get the on-ramp address, because on-ramp is like the bridge. So if it's not there for the destination chain selector, then we are going to revert. So here they try to, I think this is still the lexicon, because right now if you only have one ramp, then you don't need to use the destination chain selector as an index. Okay, but anyway, I'm sure this will be improved in the future. And next thing is they're going to check what kind of fee token is used. What do you pay? By what? So the first case is by the native token. If that's the case, it's going to calculate the fee by calling the onRamp get fee function. So get fee function is going to be charge a fee that chain specific. Different destination chain might charge the different fee rate, and then based on the length of the message, and then it's going to return you the fee amount, and then you're going to check if you have sufficient amount of the native token paid. If you have it, then you are going to convert it into the wrapped token and then transfer to the on-ramp. Okay. Otherwise, we are going to, if it's not native token, then we are going to, in a similar way, calculate the fee based on the destination chain, and then we're going to send it to the on-ramp as well. So by now, the on-ramper will own the fee that the user have to pay in order to send a message across the bridge. And then the next thing is going to, so that's just for the fee that we have to pay for the bridge fee. The next thing is we are going to send over all the token in that amount to the pool. For every token and the destination chain, there is a pool over here that you can send all the tokens over there first. I was curious why this is not done in the log and the burn part, but we're going to talk about this again. So this is something I don't quite understand, but anyway, this is already, all the token already sent over to the pool that need to log it. And then it's going to call the forward from router of the ramp. So it's going to call this method in the on-ramp. So this is the main method that is doing all the work of sending all the messages. So let's look at what it forward from router is doing from the call graph. It's actually look like this. We're here right now. So the user is going to call user friendly CCIP send, and then which is going to call the forward from router. But forward from router actually basically doing two things. One is going to log on and burn the token, and the other one is it's going to process the message args. Basically, it's going to fill out all the fields of the message, because when we send a message to the other chain, we cannot send directly. So basically, we just emit an event, and that event will be very sophisticated, contain all the content of the message. So the log or burn single token, again, will call the log or burn implementation of a particular pool. So this part is CCIP, but the pool part, the source pool part is really application dependent. Different application, they can have their own pool logic. So we consider this part, the first of all part over here is belong to this CCIP. So that's we call TCP, I believe, trusted code base. But this source pool is not considered as part of the TCP, so we cannot trust it. So special caution have to be taken to make sure that the source pool logic or implementation is not going to mess up the whole CCIP protocol. Okay, so let's go back to the code of onRamp over here. So we're going to call the forward from router. And first thing we do is we are going to do a energy scar enter. The reason we do that is because we have untrusted, especially we have untrusted pool logic. We have to make sure the pool logic is not going to call this again and enter into the agency. So so we're going to, first of all, we need to get the configuration for a destination tool chain. If the configuration is not right, we are not going to allow the send message to the destination. So first of all, original sender cannot be zero address. I don't know why you need to check this. It's impossible to have this. Anyway, it doesn't hurt. And then it's also the regional sender is in the allow list. I don't think zero will be in the allow list anyway. And then this line, make sure it's called by router. And then this is also the router for destination configure. So this means every destination chain might have their own router. I wonder if the next step of improvement for CCIP is going to be have just one router for one chain, because right now for every destination chain there's one router. So that's something scalability should think about. And then here we also allow customized interceptor to have the application specific logic over here. So this is a message interceptor, which allow you to process the message further. I'm not sure if we can also do some improvement over here to make sure that using a low level call so that the logic of message interceptor is not going to mess up the whole CCIP. And then the next one is EVM280 RAM message. So here we are going to create a new message. So this is the most important part. We are going to create a new message and then we're going to emit an event. So this is the message we're going to basically send over across the chain. So I already put the structure over here. So this is actually what the structure looks like. There's a header over here, and then there's also the message content, including the last part. It's another structure which specify the token transfer information. So and then this is the real field that we need to look at. So this is the head, it's unfolded. So the head including message ID, it's to be filled later. And then the source chain selector, which is the current chain, the destination selector provided as argument from the forward message argument, and then sequence number is interesting. We are going to increase the sequence number by one. So this destination chain configure, that means for every destination and a source chain. So this is a pairwise sequence number. For every pair source chain and a destination chain, you're going to increase the sequence number one by one. So this is across different sender and different receiver. And so it's a pair per source chain and the destination chain. And then the nonce is going to be 0 initially, it's going to fill later. And then over here, we put the original sender, which is the color of the router CCIP IP send. The data is copied from the original message. This is a new message format. Extra args, we're going to fill it out later. Receiver, specified in the message receiver. Fee token, message fee token. And by the way, by now, the fee token should be, if it's native token, it should be the wrapped token already. And then the fee token amount. And then finally, this also need to be filled later. This is basically the equivalent amount of fee in Chainlink. Okay, I think this is probably for accounting purpose. So eventually they can calculate how much, because different token have different price. So they just convert everything to Chainlink, and so you can get some idea how much money is earned by the bridge fee. And then finally, the token amount is going to be a structure that capture how many token for each token, how much of them are locked and or burned in the pool. All right. So let's go back to our original code over here. So I already explained this part. So the next question is how we are going to fill out every single field there. So the first field we are going to fill is token amounts, which is the last argument, the last field over here. And this is actually a structure of EVN to any token transfer. It's an array, and then so it's going to be one element for each token. And what it's going to look like is like it's going to be like this. Okay. So this is the EVN to any token transfer from one element. It looks like this. You have the source pool address, which pool is going to be used to lock the token. And then the token destination token address. In other words, in the chain 2, what kind of token you're going to receive, the corresponding token on chain 2. And then there's also extra data. This is supposed to be returned by when we lock the token on the pool, it's going to be returned by the pool. So the pool is going to give us some back extra data that you can pass to the chain 2. So that in chain 2, when you execute, when you transfer the token, you can have additional logic there. And then this is copy over from the input, from the message input, token amount, how much we are locking. And then this is supposed to be returned by the burn and the lock, by the lock or burn single token as well. I don't know why it's set to empty string. It's supposed to be filled by this, but we will take a look again there. So so here you will iterate through all the input, through all the input token amounts, which is specify which token and how much we want to transfer, and then other 3 arguments. So let's take a look at the log or burn single token over here. So essentially, checking cannot move 0. Then it's going to, from the registry, it's going to look up what pool should be used. Again, here I'd like to comment. There might be a scalability improvement we can do right here, because right now it's like for every source chain and a destination chain and the token, there's going to be a source pool. So there might be too many source pool, because every source chain, every destination chain, and for each of them, there's going to be a tool. Is it possible to have only one pool for all only one pool in each chain? that would be make it really more scalable. But anyway, let's go move forward. So if the pane doesn't exist or doesn't support the CCIP interface yet, then we simply revert. That means we cannot transfer this token. Otherwise, we are going to call the poor log or ban. So this is going to be out of the TCP now. This part cannot be trusted. So I think ideally this should be also called by protected by low-level call. So in this way, it's not going to mess up by suspicious pool. And then after that, so it's going to return this pool return data. Actually, what is pool return data? This is returned by the pool.log or ban. It's returned two fields. One is what is the destination token address? In other words, what is the address of the token in chain 2? And then what additional pool data you want to provide. Right now, the implementation is provide empty, but it could be something else. It depends on the pool implementation, which is application specific, not part of a CCIP. And then once we have done that, then we are just going to return back to this structure EVN to any token transfer, which is the last argument of the new message, token amounts. So again, the last component of token amounts of the new message looks like this. Okay, what a pool is used, which is application dependent. What is the destination token address? Again, application dependent. And then the extra data, which is returned by the pool amount, is taken from the input. The destination extra data also returned by the pool. So once that's returned, let's go back to here. So either through all of these, if one of them fail, we are going to fail. And then the next thing is trying to do the second part, trying to process the message argument, which is basically passing the input message and then fill out the new message. So I'm not going to explain further. You can look it up. But basically what it's doing is calculate again the amount of fee we have to pay in terms of Chainlink. We already paid for it. Is out of order execution allowed true or false, and then converted extra args, which is a field in the new message over here, right over right over here, extra args over here, and then destination execution data per token. So that's something also returned from all of these. And then, okay, finally, we are going to fill the nonce. If it's out of order execution is allowed, then we're going to just put a nonce at 0. That's just a signal that we don't care about order of the execution of the message. Otherwise, we are going to call nonce manager to increase the nonce by 1. And that nonce will be filled here. And this nonce is actually managed for every source chain, destination chain, and also the original sender is going to be a unique nonce over here. So if you look at the nonce manager, it's going to look like this. You retrieve the kind of nonce based on the sender, based on destination, and implicitly based on the source chain, increase by 1. Then we are going to set it to new bounds and then use it to fill the nonce number over here. And then we are going to just, for every single token amount, we are going to give the destination execution data. This is for per token. We are going to do this. Okay. So this is token specific called the execution data specific, and then we are going to do a hash. So the hash is going to contain two parts. One is, of course, the new message, everything there. Keep in mind, at this point, the message ID is not filled yet, so this is corresponding to an empty message ID. And in addition, they put extra field over here, which put all these things together, source chain selector, destination selector, and then this fixed value as well as the address of the on-ramp. I understand the source chain and destination is already in the new message, but I think it doesn't hurt. So here's the final trick to send all the new message over here, and then as well as new message header sequence number. Of course, this is already including new message, but this is just for easier parsing. So you take it out, you can easily find out the sequence number. It's more easy to monitor it, and then as well as the destination chain. We don't need to put a source chain over here because the source chain already implicit. The monitoring system, the event system always know who emit which chain and which contract emit this message, so that doesn't have to be here. And then eventually we set this to false, so we are done. And then this is going to return the message ID back to the router. And then this also, the router is going to return the message ID back to the user. So the user can use that as unique identifier to check the status of that message. So that's very much of how